Welcome to Trigonometry lesson number 5, the sine law. In the few lessons before this, we've been talking about angles rotating around a circle or angles rotating around a quadrant. Now, in this lesson, we are going to talk about the sine law, and this might remind you of maybe basic trigonometry, SOHCAHTOA, and only using SOHCAHTOA. So let's take a look at these first few lessons, or these first few examples. So in each case, we want to determine the value of x to the nearest whole number. Okay, so if we're looking for the value of x, we're looking for this angle theta. Now I'm given the opposite side of my angle and the hypotenuse, in which case I know that I'm going to be using sine x in order to find my missing value. Sine x, remember, or sine is equal to opposite over hypotenuse, which is equal to my 8 over 14. And then all we need to do to find that missing angle is type this into our calculator. And once we type this into our calculator to find the inverse sine, we are going to get x equal to 35 degrees. So something you've seen before. Now we're going to move over to this next question. I'm given my adjacent side, since I have my angle of 40 degrees, and I'm looking for my missing side of x. And so to solve this, I would use cos 40 is equal to adjacent over hypotenuse, which is 19 over x, and I rearrange to find my hypotenuse, and I'm going to get x is equal to 25 degrees. Or sorry, not degrees, just 25. Okay, so that's my answer for B, where x is equal to 25. Now remember, if you're solving for hypotenuse, basically your x and your cos 40 will switch places, and it would just be 19 divided by cos 40, and that's what you would type into your calculator. Okay, now let's move on to this next example. So use SOHCAHTOA to determine the length of BC. So the length of BC then we're looking for is right here. We want to know the length from B to C. Work to 3 decimal places and answer to 2 decimal places. So this is just giving us an indication of when we do input an answer into our calculator, we are going to use a final answer of 3 decimal places for further answers. So let's look at the first side we need to calculate. We need to find what x is. We're going to need to find out what this side is in order to find out what this side here is. Alright, so if I'm looking for x, I have the hypotenuse, and I also have an angle theta. And so if I have a hypotenuse, I have this angle, I'm looking for this opposite side, so I'm going to use sine. So sine 20 degrees is equal to x over my hypotenuse, my r value, which is 12.50, and I'll rearrange this to solve for x. X is equal to 12.50 sine 20 degrees. I'll type this into my calculator. I'm going to get an answer of 4.275, and that is in centimeters. And so I know that B to D is going to be 4.275 centimeters. Now let's move on to, well, I still don't know how long B to C is, so I need to solve for y. But in order to solve for y, I'm going to need to find out what this value of h is, because if I look at this, I can't use my any of my trigonometric ratios, because I don't have well, this isn't a right triangle. The only right triangles are located inside if I draw this altitude down the middle. And so I'm going to have to find out what that side h is in order to find out what y is. So we'll do that now. And if I'm looking for h, I again have the hypotenuse and I have my angle, but I don't have this adjacent side to my angle. If I look at this side, this will be adjacent to this angle. So if I'm using a side that's adjacent, SOHCAHTOA, I'm going to be using cosine. So cosine 20 is going to be equal to h over 12.5. Rearrange for h. 12.5 multiplied by cosine 28 degrees. And again, we'll type that into our calculator and we'll get an answer of 11.746 centimeters. Remember, we're working to 3 decimal places. So when I get these answers, even though they're longer in my calculated answer, I'm going to round to 3 decimal places. And then my final answer will be up to 2 decimal places. So now I know what h is. It's 11.746. I can now find out what y is. And I'm going to do that by finding the tan of y. So tan, if I'm looking for y, I now have I now have this length here. I have this height. And so if I have the opposite side, I'm looking for my adjacent side. Or if I'm going to use tan 55, I have this adjacent side and I'm looking for my opposite side. And so tan 55 degrees is equal to y over h, opposite over hypotenuse, which is equal to y over 11.746. We'll rearrange to find y, and since I filled in h here, I'll just bring that up there. So y is equal to 11.746, that's decimal there, tan 55. And we're going to get a value of y being 16.775. Okay, and that is also in centimeters. But remember, we're looking for the length of B to C. So in order to find length BC, we will have to add my x value, which was 4.275, plus my y value, which was 16.775. 4.275 plus 16.775 centimeters is going to give us 21.05 centimeters. And that is your final answer. So I would recommend pausing here, and then if you want, you can attempt the first 2 questions. Okay, so for this lesson, I'm just going to explain why we're using something called the sine law. Now, before we've been using SOHCAHTOA, and SOHCAHTOA is useful for 90-degree triangles or right-angled triangles. But now we're not working with right-angled triangles. So if you look at this triangle in my diagram here, you'll notice that none of these angles are going to be 90 degrees. Now, yes, we could make a 90-degree triangle inside, but what if we're working with a problem where we can't actually do that? And so in this triangle ABC represented, we'd say that the length of side opposite A, of angle A, is A. And so if this was a triangle as we're working with ABC, the length of this side opposite, we would name this side A. We would name the length of the side opposite B, B. And then we would name this length opposite of C, angle C, lowercase c. Okay, so in this equation, all your uppercase letters are going to be angles, and all your lowercase angles, or lowercase sides, lowercase letters are going to be sides. Okay, so I'll say that again. The uppercase letters are angles and the lowercase letters are sides. And so in any triangle ABC, it'll follow this ratio. A over sine A is going to be equal to B over sine B, which is equal to C over sine C. And we can reverse those ratios so that sine A over A is equal to sine B over B, which is also equal to sine C over C. Alright, so this is a formula that you are now going to need to use all the time. But it is also one that is on your formula sheet. Okay? And so it's more common to see it written like this, and this is the one we're going to be using for this lesson. So let's look at a quick proof of the sine law. Now, if you need to pause or rewatch this portion of the video, then that might be very necessary, since sometimes this kind of stuff can be not difficult, but just confusing to follow at first. Alright, so the diagram below shows the same triangle ABC placed with base AB on the x-axis. So our base is on the x-axis, and that is AB, and in both cases it's drawn here. The only difference is we've reversed the triangle in this second diagram. Okay, but both of them have the base AB on the x-axis. In diagram 1, the origin is at A, and in diagram 2, the origin is at B. And so remember, when we're talking about the origin is 0, 0. Okay, so they have different points at the same origin. So the line CD is drawn perpendicular to AB. And so remember what perpendicular means. If I have two lines that are perpendicular, it would look like something like that. And then, yeah. So complete the following work to show that A sine A is equal to B sine B. Okay, so we know what sine is, right? Sine is equal to my opposite over hypotenuse. Alright? So sine is equal to opposite over hypotenuse. Let's keep that in mind for proving this the sine law. Now, if sine A is equal to CD over AC, so CD being from here to here, and remember that we're thinking about sine A, and remember this capital A means that we're using this angle here. So sine A is equal to CD over AC. CD over AC is just saying my opposite, CD, over my hypotenuse, AC. And of course, if that's my sine A, then CD is also, since CD over AC is equal to CD over B, because CD is still my opposite, and we can also say that AC is this side B. And so that would mean that if I were to rearrange this to look for angles or side CD, I could say that B multiplied by sine A is going to be CD. So then we could say that then if we're looking for sine B sine A, we could say that A is equal to sine B if we were to reverse and look for this side over here. Because remember, these sides are going to be opposite, just like we did in our first triangle. Okay? So now, let's look at this second proof. So in diagram 2, sine B, so if I'm looking for sine B over here, then sine B is equal to CD over BC, and that is also equal to CD over A. And so this is A. And remember, A is opposite of angle A. Just like B was opposite of angle B. Okay, and if we were to rearrange this, because in this case CD is opposite of our angle and BC is our hypotenuse, if we were to arrange this, then CD is also equal to A sine B. And so if CD is equal to B sine A and CD is equal to A sine B, then B sine A, then these two also must equal each other if CD is equal to CD. Alright, and so the next part, if we divide both sides by sine A and sine B, and then we want to know what the result is going to be. And so basically, if I divide this side and this side by sine AB, sine A sine B, so sine A sine B. I want to know what I'm going to be left with. Sine A, sine B. And so if we look at this, our sine A's are going to cancel out, and our sine B's are going to cancel out. And so what we're going to be left with is B over sine B, which is going to equal A over sine of A. And so if we repeat the work above with AC and place that on the x-axis, we would get the other result that sine A or A over sine A is equal to C over sine C. But this is basically how the sine law works. Now let's look at questions where we're actually going to use it. And if you found just this whole process daunting, don't worry, I'll sit down with you and I'll re-explain it. I'll just show you why it works. Okay, why this relationship between the lengths and the angles works for a triangle that is an obtuse angle or acute angled triangle. Okay, now so let's look at a class example number 3. Now to use the sine law, this is important. In order to use the sine law, we need to know 3 pieces of information. So the information we need to know is if we're using A over sine A is equal to B over sine B, we need to know at least 3 of these 4 things. At least 1 or 2 sides and at least 1 or 2 of the angles. Okay, so let's try this first question. Triangle ABC from class example number 2 is shown. Use the sine law to calculate the length of BC. Okay, so we are looking for the length of BC right here. And compare your answer to the SOHCAHTOA method. Alright, so the first thing we're going to do is let's actually label our sides. If this is angle A, then this is going to be side A. And make sure you use lowercase notations here. If this is angle C, then this will be lowercase c. That looks like an A. And then if this is angle B, then this is going to be side B. And remember, it's a lowercase b. So the next thing I'm going to do is, since I'm using the sine law to calculate this length of BC, I'm going to start writing A over sine A is equal to, since I have my side C, I'm going to use this side, is equal to C over sine C. Okay, so now remember, I need to know at least 3 pieces of information in order to solve this question. Now let's see if I have those pieces of information. I need to know side A. I don't have that yet, but do I have my angle A? I do. It's 75. Now I need to know what C is. Do I have my side C? I do. It's 12.5, and I also need my angle C, and I have that, which is 35 degrees. Now I have those 3 pieces of information, so I can solve this question. Okay, so I'm looking for my value of A, so that's going to remain my unknown, but I know that my angle A is 75, so that's going to be sine 75 degrees, and that is going to equal C over sine C, so that's going to equal 12.50 over sine C, which would be sine 35 degrees. And now the next thing I need to do is I need to just rearrange this equation to solve for A. And to do that, we are going to cross multiply. Okay, so I'm going to multiply these 2 terms together, and I'm going to multiply these 2 terms together. And I'll separate them on either side of the equation. So what that would then look like is A sine 35 is equal to 12.5 sine 75. And again, I'm looking for A, so I'm going to have to get rid of this sine 35, which means I'll have to divide both sides by sine 35. And once I do that, I'll be left with 12.50 sine 75 divided by sine 35 degrees. Okay, and I'm going to put this into my calculator, and if I do put this into my calculator, I am going to get an answer of A, which is also equal to BC. So BC is equal to A, and that is going to equal 21.05 centimeters. Okay, and the next thing that you can do is compare it with the SOHCAHTOA method. And so if you want, you can make this a right angle triangle, and to do that you just draw your line down the center. Okay, for this next example, we want to use the sine law in the triangle shown to determine the measure of angle ACB to the nearest degree. Okay, so if we're looking for angle ACB, and that means we're looking for angle ACB. And when it's noted like that, remember, that means that we're looking for this angle C. We're looking for the one in the middle. Okay, and so let's use the information given to, first of all, we need to determine, well, let's figure out angle, let's figure out them all. Now, but we do specifically need angle C. Alright, so if I have 9.4, remember this is going to be side A, and I'd recommend starting out with these questions. This is going to be side B, and this is going to be side C. Okay, so if that is all, if those are the sides I'm looking for, then let's start putting these in the, let's just start plugging these into my equation. Okay, so if I have my known value of B, which is 6, and my known value of A, which is 9.4, and a known value of 110 degrees, a known angle. And so those are three pieces of information that I can use. Okay, so I can use B and I can use my A's. And so if I have sine, I don't have sine B, and let's flip this equation around. And I do have B, and I also have sine A, which is 110, and I also have side A. Okay, so if I'm going to find sine B over 6 is going to equal sine of 110 degrees over A, which is 9.4. And now again, we need to rearrange this in order to solve for sine B. And so this is going to be sine B multiplied by 9.4, and that's going to equal 6 times sine 110. Alright, and so remember, the way I got this was I just cross multiplied. And now we're going to have to divide by 9.4 in order to isolate sine B right here. And so sine B is going to equal 6 sine 110 divided by 9.4. And when you plug that into your calculator, you are going to get an answer of 6 sine 110 divided by 9.4, 0.5998. So I'm just going to round that to 0.5998. But I'm looking for my angle, for this angle B right here, and so I'm going to go second function sine in order to find the angle. I'm going to type in this ratio, and I get an answer of 36.85, which I'm going to round to 37. So I know that sine B was 0.5998, but my angle B is equal to 37 degrees. So that was the angle B there. Now I can find out what my angle ACB is, or angle C. And so in order to do that, remember that in our triangles, they need to add up, all our angles need to add to be 180 degrees. And so I'm going to subtract all these from 180 minus 110 minus 37 will give us an angle of 33 degrees. For example number 5, a surveyor measures a baseline, which is PQ, 440 meters long. So we know that this line PQ is going to be 440 meters long. He takes measurements of a landmark R from PQ and finds that angle QPR is 46 degrees. So remember, if it's angle QPR, then that means that angle P here, angle QPR is 46 degrees. And he measures PQR, so PQR to be 75 degrees. So we know that that is going to be 75 degrees. Okay, so right away that gives us a third piece of information. That gives us our third angle, because we know that these two angles and this unknown angle need to add up to be 180. So that will give us angle PRQ. And so angle PRQ is going to equal 180, subtract 75, and subtract 46, which would give us an angle of 59 degrees. And so now we know that that angle is 59 degrees. Okay, and so what we want to do though is we want to calculate the perimeter of triangle PQR. So we want to know what angle, we want to know all the sides, because we want to know what the perimeter is. And remember, if we want to know the perimeter, we need to add up all of these sides together. And so remember, we need to have 3 pieces of information in order to solve any question, and we do, because remember that PQ, or R, is equal to 440 meters. Okay, and so now we can get started. So I know that I'm looking for this side Q, so let's start by looking for side Q. Is going to be Q over sine Q, and that's going to equal R over sine R. Okay, and so I know that Q, I don't know what Q is, but I know what sine Q is. That's going to be Q over sine 75, and that is going to equal 440, which was R, over the sine of R, which was sine 59, which is that unknown angle that we found. And so now in order to find Q, remember, I need to cross multiply these, and one thing, once we get better at doing this, we'll be able to skip that step, this step right up here. And so I'm just going to immediately rearrange for Q, just so I don't run out of room. Q is going to be equal to 440 multiplied by sine 75, and since I know that Q is going to be Q multiplied by sine 59 over here, I'm going to eventually have to divide by sine 59 to get Q by itself. So I'm just going to do that right now. Divided by sine 59. Okay, so that will help us solve for Q. And so let's see what that is. We go 440 sine 75, and I'm going to divide this by sine 59, and I get an answer of 495.83. Okay, so 495.83 meters. Okay, so now we have 2 sides. Right, so that was 495.83. Now we need to find side P. And so let's set up our equation. P over sine P is equal to, let's use R again. R over sine of R. Okay, we could, now that we know what Q is, we could say that P over sine P is equal to Q over sine Q, but I don't know, just because this 440 is, it's a nice number, I like it, so that's what I'm going to use. Okay, and so let's plug in all the information that we have. So P over sine of 46, since P is right across from the side P over there, so sine 46 is equal to 440 sine of 59. And again, I'm just going to, well actually, I'll do it the long way this time just so you know how I skipped that step. So P, if we cross multiply the tops and the bottoms, we'll have P sine 59, and that is equal to 440 sine 46. So this is what I was saying earlier, I was just going to skip that step just because I know I was going to cancel it out anyways and bring it to the other side. So what I did was I divided by sine, I'm going to divide by sine 59. Okay, And so now I'll rewrite that. So P is equal to 440 sine 46 divided by sine 59. And when you type that into your calculator, sine 46 divided by sine 59, you're going to get 369.25. Okay, and so remember we wanted to find out what the perimeter was. So the next thing we're going to do is add the perimeter is equal to all the sides added together. So that's going to be P plus Q plus R, which would be 369.25 plus 495.83 plus 440. And we're going to round to the nearest meter here because that's what our question asked us to do. So 369.25 plus 495.83 plus 440 is going to give us 1,305 meters, and that is going to be our final answer. Sorry, that was my printer. But anyways, for this question, I need to calculate the area of triangle PQR to the nearest 100 square meters. Okay, so let's remember what that triangle looked like. We had P, we had R and Q down here, and this was 46 degrees, and then we had this side, which was 495.83 meters, and then we had 440 meters, and then this one was what, 369.25? 369.25. But I'm not even going to fill in the rest of the triangle because we don't actually need all the information. Remember, we're looking for the area here. And so we're going to have to remember what the area of a triangle is. Remember, the area is equal to 1/2 the base times the height. So we are going to need the base. That side we will need, but we also need the height of this triangle. And to find the height, we're going to have to find what that dotted line going straight up is. Okay? Now, if we do not have this number, and this is the h, the height, then we can use one of our trig ratios to solve that. And remember, we don't know if this is going to come down exactly halfway, so we can't assume that this is going to be 220 over here. So we're going to have to use this hypotenuse that forms a 90-degree triangle now with our height. And in order to do that, we're going to have to use opposite over hypotenuse or our sine ratio. Okay, so remember that sine is, sine 46 is equal to opposite over hypotenuse. Our opposite is going to be h over our hypotenuse, which is 495.83. If I rearrange to find h, remember I'm just bringing this up here, I'm bringing it up here because I'm multiplying by this number. It's going to be 495.83 sine 46, and that'll equal h. You dump that in your calculator, you're going to get 356.67. Okay, so that is what my height is, and I have my height, I have my base, I can find out what my area is. And so my area is now going to equal 1/2 times 440 times 356.67. And we want it to the nearest 100 square meters. So let's say that 0.5 times 440 times 356.67. Oh, made a mistake there, 356.67. I'm going to get 78,467. We want it to the nearest 100 square meters, and so if I want it to the nearest 100 square meters, then I'm going to round up here. Okay, so that 78,467.4, we're just going to round that to 78,500 meters. And there goes my printer again, but that's okay because that is it. Now remember, if you need to watch anything, just go back and pause wherever you want. But some of these questions you might even be able to start right now. And that's questions number 3 to 11.